now we so now we will move to the next topic, that is called as declaring objects. Okay. Okay. See, in the previous program, they have already declared the objects, but still we have the topic called as declaring objects because it's like not very much similar to C++ as we create objects in C++. Their memory representation is different, and here it is different. So we'll come to know how it is. So when we create a class, we are creating a new data type. So we came to know from the declaration of class. So whenever class is created, so we are creating new data type. So we can use this type to create objects of the type. The new operator dynamically allocates, that is memory at runtime for an object and returns a reference to it. In Java, the memory for object of all classes must be allocated dynamically. See, here the meaning of this is like when we consider C++ way of creating an object and Java way of creating an object. See, generally in C++, if you look at this object statement, box, my box. So this much is enough to create an object. Okay. And if I want to call a constructor, then I have to put like this. Okay. Within this, I should mention some value, that is parameterized constructor. Otherwise, if we don't write anything, that is default constructor. And if I don't use parentheses also, it is default constructor. So in C++. So this much statement is enough to create an object in case of C++. But when it comes to Java, what happens? We have to create an object like this. That is, we have to use the new keyword. See, if we use the new keyword, then only we will get the memory for an object. See, memory representation means we just consider this diagram. So if we think that there is no memory representation for an object, then we can say like this. So you just look at this diagram. First column, box class. In that width, height, and depth. So just I have mentioned the class. For the class variables, width, height, and depth, but there is no memory representation. That means I cannot store values for these variables. Okay. When I can store values means when object is created. So when object is created means when new keyword is used. When new keyword is used, actual object is created. Then we get a memory. You look at the second column, you will come to know. In second column, so I have put extra box for the variables, width, height, and depth. That indicates where you can store the value. That indicates we got the memory. Okay. So that means, see, when we write the statements, statement like box, my box is equals to new box, then memory allocation happens. Remember from this statement, that is class name, object name equals to new keyword, and again class name with parenthesis. See, always if the function name, that is method name, and class name are same, that is called as constructor. Okay. See, in this entire sentence, first time what you have written box, that is the class name. Last time what you have written the box, that is constructor name. Okay. Class name and constructor name will be same. In C++ also the same concept. Class name, constructor name will be same. Okay. So the above statement combines two steps. It can be written as follows. That is box, my box. So one statement you can write like this. That is declare reference to an object. Then another statement is, you just look here. Okay. My box is equals to new box. Two statements. We have written this statement into two parts. That is box, my box. Next, my box is equals to new box. See, when we write in this format, what happens? Just after executing this statement, box, my box, it declare a reference to an object, but not the memory. So okay, try to understand. It declare reference to an object. It will not create a memory. If memory is not created, you cannot store the values. Because in computer, if we get the memory, then we can store the values. Next line will create a memory for us. Okay, my box is equals to new box, because new keyword is there. Wherever we come across a new keyword, at that line memory will be allocated. So allocate a box object, that means memory. Okay, so box, my box. This statement, this line declares my box as a reference to an object to type box. See, whenever I say reference to an object, their memory will not be there. Okay, memory concept will not be there. That's just, it is a reference. In case of C and C++, this reference concept is like a pointer. In Java, pointers are not there. Okay, in Java, pointers are not there, but references are there. So this statement will create a reference. No memory allocation happens at this stage. So this statement is very important. Whenever we write class name and object name, and if you put the semicolon, just by writing this much, no memory is allocated. That means we cannot store the values. Okay. The object mybox contains a value null. If you use the object mybox at this point, will result in compile time error. Okay, that means immediately after executing the statement box mybox, object reference is created, but not the actual object. If the object reference is created, no memory will be there in my box. Okay, so if you try to use this my box in further program, you will get an error. See, you just look at this diagram. Okay, statement is box my box. That effect is null. That means object reference is created, but not the memory. So only have written in place of my box null. Okay, that means no memory. Okay, statement is box my box. When this statement is executed, that effect is null. Object reference is created, but not the memory. Okay. Next, when we go to the next statement, what happens? That is my box is equals to new box. This line allocates an actual object. That means we get a memory. So whenever new keyword is there in the statement, we get the memory. Then we can understand like this. Just you look at this. You can understand like this. See, my box width, height, depth. I have put the second column here. For width, height, and depth, I have put the second column. That means we got the memory now. Okay, for variables, width, height, and depth. So just a spelling mistake here. It is a depth, D-E-P-T-H. Okay. See, how did we get these variables? Means it is present in the they are referring to this class only. Okay, whatever the class we used initially, for this class only they are referring. That means in box class we have width, height, and depth. These three variables are present in the class box. For that class only they are referring. Okay. So when we write box my box semicolon, we will not get any memory. So we cannot write the memory representation. You should just write null. When we write my box is equals to new box, then you can write this memory representation. So this is the memory representation when we say memory is allocated. At the next line, we can start storing the values. That means you can write like this. These statements we can start writing. My box dot width equals to some value, height equals to some value, depth equals to some value. That you can write. So whenever we use new keyword, memory will be allocated. From the next line, we can start storing the values. Okay. Okay. A closer look at new keyword. So they are explaining about the new keyword, what actually happens when we use the new keyword. Okay, the new operator dynamically allocates memory for an object. So in programming language, we have two types of memory allocation: static memory allocation, dynamic memory allocation. So new keyword will allocate the memory dynamically. Okay, for a variable and for an object, even for an array also. Okay, so general form of writing new keyword is variable is equals to new class name. So here on the left hand side, they are telling var. In general, it is okay, because for pointers we say variables. For classes and objects, here on the left hand side, instead of var, you can write object. When you are writing in general, you can use any term. Okay, just for reference. When you are writing particular example, you have to write the object name. So var refers to object, is equals to new is a keyword, class name. So opening parenthesis, closing parenthesis. As I said, it indicates constructor. Okay. Say var is the variable of type class. So whenever we say of type class, that is nothing but an object. So variable of type class is nothing but an object. Okay. So here var refers to object. Class name is the name of the class. The class name followed by the parenthesis specifies the constructor for the class. As I said, wherever you use the class name with parenthesis, that is called as constructor. If you are not giving any values, that is default constructor. If you are giving values, that is parameterized constructor. If suppose if I give one value, say 10, okay, constructor with one parameter. If I say 10, 20, constructor with two parameters. So that indicates parameterized constructor. So there are many types of constructor, out of which we say constructor, that is default constructor, parameterized constructor, copy constructor. In that way, many types of constructors are there. So these type of constructors are called as default constructor. That is within parentheses if you don't write any values. Okay. So if you want to indicate that it is a constructor, compulsory how to write parenthesis. Class name followed by the parenthesis specifies the constructor for the class. So for this type of brackets, you call it as parenthesis. Okay. So this on the right hand side, class name with parenthesis, this is called constructor. Okay. Java will supply default constructor if explicit constructor is not specified. That means in the class, if you don't write the constructor, Java will supply default constructor. I hope you people know how to write the constructor. The example I will tell you. See, if this is the class, okay, class box, if you want to write the constructor, that means explicit constructor. Explicit means manually, implicit meaning automatically. That means Java will provide automatic one constructor. While executing for this class, constructor will be created. See, here it is not there. While writing the program, we have not written. But while executing, Java will consider default constructor. So that we cannot see. But internally, it happens. Externally, that means if you want to write explicit, that is manually. So I should write like this. Box, opening parenthesis, closing parenthesis. Then like this. Okay. This is called as constructor. Constructor means it looks like a function only. It is a member function. So this is a constructor. It looks like a function. Class name, constructor name will be same. So this is how we write explicit constructor. That is manual constructor. If I don't write this, Java will supply default constructor. While executing, it happens. Okay. So that only they're telling here. Java will supply default constructor if explicit constructor is not specified. New allocates a memory for an object at runtime. So we have two types. Compile time and runtime. Compile time means before the program is executed. Runtime means during the program execution. You should not say after the program is executed. It is not like opposite words. Before, after. Before the program is executed means compile time. During the program is executing means it is runtime. So during the program execution, okay, that is called as runtime. So during runtime, memory will be allocated. If the memory is allocated before the program is executed, that is called static memory allocation. If the memory is allocated during program execution, that is called as dynamic memory allocation. So new keyword is used to allocate memory dynamically. Dynamically means it is runtime. Okay, static means it is compile time. Okay, assigning object references. So here something interesting is there here apart from C++ declaration of objects. So here we will see what it is. Okay, just a minute. Consider the example, box B1 is equals to new box. See, one object have created, right? B1 is the object, okay, for class box. Next, if I say box B2 is equals to B1, see, one more thing I should tell for you. Wait. Okay. See, whenever you consider assignment operator, that is equals to operator, this is called assignment operator. Single equals to is called as assignment operator. See, when we consider this, if I write A is equals to B, I write LHS part and RHS part. Okay. So in case of these type of statements, what you have to consider is LHS variables data type should be same as RHS variables data type. If it is not same, it happens converting from one data type to another. That topic is there, type conversion. So that is a different topic. We should know how it is converted. On left hand side, which data type will be there, right hand side, which data type will be there. That is different concept. But right now, what we will understand is LHS data type and RHS data type should be same. That is, now how I should declare is either I should declare int a comma b. That means both should belongs to int, or I should say float a comma b. You just try to understand this concept because the same concept is used in the creating object. Okay, I should use like this. If I write the statement like int a, okay, float b, we can say this statement is wrong. For this particular concept, what I am telling, that means LHS variables data type, RHS variables data type should be same. So if you are declaring variable a in data type int and variable b in data type float, it is not matching because LHS variables data type is in, RHS variables data type is float. Actually, type conversion happens. Just we will try to understand like that. LHS variable data type should be same as RHS variable data type. Okay. So whereas first two statements are correct, you should use either one. Both variables of type integer or both variables of type float. Similarly, now if we consider box B1 is equals to new box. Okay. this one object have created, right? Next, I'll create one more object, box B2. If I want to assign B1 to B2, I should write like this. So B2 should be on the left hand side, B1 should be on the right hand side. I am assigning from B1 to B2. Okay, not from B2 to B1, B1 to B2. For this, one more formula I will tell you. Say whenever you use assignment operator, you just remember this formula. To is equals to from. Okay, from which variable you are copying, write it on the right hand side. To which variable you are copying, write it on the left hand side. 2 is equals to from. Okay, don't get confused here. 2 is equals to from. From which variable you are copying, write it on the right hand side. To which variable you are copying, write it on the left hand side. Now, in this present scenario, I am copying from B1 to B2, not B2 to B1, B1 to B2. So I have written B1 right side, B2 left side. Now, if suppose instead of box, if I have taken some other class name, let me consider like student. If I written one class in the program, two classes, that is box class and student class. If I taken class name student, B2 is equals to B1, this statement becomes wrong because this B2 object belongs to student class, B1 object belongs to box class. Okay, B2 object belongs to student class, B1 object belongs to box class, so which is wrong. Okay, that means, so what I'm telling is like left hand side variables data type, right hand side variables data type should be same. So only what we have to do, we have to write here it as box, then it is correct. Otherwise, if you're writing student only, and that is student B2 is equals to B1, at least here you make it as student, then it will be correct. Student B1 is equals to new student. Okay, whereas where student is a class name. So this is correct now because B1 belongs to student class, B2 also belongs to student class. This is correct. But here if you are using class box and in the next line if you are using class student, that is wrong. Both belongs to different data type. That is different classes. So it is wrong. So that both should be same in case of class and objects. So here they are telling box B1 is equals to new box B2 is equals to B1. Now we will see what happens at this statement. Okay, see here B1 and B2 both refers to the same object. Any changes made to the object through B1 will affect the object to which B2 is referring, since they are of the same object, that is class. This situation is shown below. You just see it. Like this, you have to write the memory representation. Box object, that means class. Okay, so you have to understand it like a class. In box object or class, we have the variables width, height, and depth. So B1 is also pointing to that same object, that is same class. B2 is also pointing to the same object, that is same class. You just compare this diagram with the previous diagram, you will notice the difference. You just see now. Okay, so I will bring the diagram down. I will try to understand this. Okay. You just compare here. In this diagram, my box 1 is an object, my box 2 is also object. But you have two different copies of memory. You just see. For my box 1, width, height, depth is there. For my box 2, width, height, and depth is there. So if you store the values of my box 1 is different from values of my box 2. Whereas when you look at this diagram, we have two objects, B1 and B2, but for both the objects, only one copy of memory is present. This we have to understand. Only one copy of memory is present. If you store the values for B1, it will affect B2 also. If you store the values for B2, it will affect the B1 also. Here, B1 is the actual object, B2 is the object reference. Try to understand. B1 is the actual object, B2 is the object reference. But whereas here, my box 1 and my box 2 both are objects. Because see, in the program what we have written for the diagram, box my box 1 is equals to new box. Okay, then for my box 2 also I have written the statement like that only. That is box my box 2 is equals to new box. You just compare the statements, you'll try to understand. For both the variables, for both the objects, I have used new keyword. So only I am getting two separate memory. But for this, for B1, I am using new keyword. So object is created with memory. For B2, I have not used new keyword. So if new keyword is not used means new memory is not created. The word new itself tells new thing. New thing means new memory. For B1, new memory is created. That is separate memory. For B2, memory is not created. New memory is not created. Then B2, for which memory it should point, that is the question. Object is created, object reference is created, but for which memory it should point? Wherever B1 is pointing, that means wherever we have indicated the memory for B1, for same memory B2 should also point. Okay, so only you just try to understand the sentence. Here, B1 and B2 will both refer to the same object. This sentence is very, very important. B1 and B2 will both refer to the same object. So only I have drawn this diagram. Okay, you cannot draw diagrams for B1 and B2 like this. Okay, it is wrong. That means you cannot take the separate memory. So you have to take only one set of memory and both objects should point to the same memory. Okay, because for B2 I have not used a new keyword. I have assigned B1 to B2. So B1 and B2 will both refer to the same object. Any changes made to object to B1 will affect the object to B2. That means if you try to store the values for B1, automatically you can say it is storing for B2 also because both are referring to the same memory. Understood? So this is called as object reference concept. In case of Java, whenever we say object reference, it will refer to the same memory. You will not get different memory. If I want to get the different memory, that is new memory, then you have to use the keyword new. Okay. Okay. So here B1 and B2 will both refer to the same object. Any changes made to the object through B1 will affect the object to which B2 is referring, since they are of the same object, nothing but a class. In the bracket I have written class for your understanding purpose. Okay, they are of the same object, right? Then this situation is shown below. That is, this is. And if you compare with this diagram, you will come to know how it is different. In case of this diagram, for both my box 1 and my box 2, I use the new keyword, so I have got the different memory. Whereas in case of this diagram, only for B1 I am using new keyword, for B2 I have not used the new keyword, just I have written B2 equal to B1. So only one set of memory, for that only both should point. Okay. In the next statements, you see. Okay. Okay, box B1 is equals to new box, right? Box B2 equals to B1, right? Next, if I say B1 is equals to null, okay, if I say B1 is equals to null, here B1 has been set to null, but B2 still points to the original object. See, this point is very important. A little bit I feel it is difficult, but try to understand. B1 has been set to null, but B2 still points to original. That the meaning of that is, see, if you are making B1 is equals to null, you cannot store the values for width, height and depth by using B1. If you say B1 is equals to null, you cannot store the values for the object B1 by using width, height and depth, because you said B1 is equals to null. So you see this diagram. So B1 null, you cannot store the values. What about B2? It is still pointing, because before you have written B1 is equals to null, we have written box B2 equal to B1. Okay, before we have written B1 is equals to null, what we have written? Box B2 equals to B1. See, after execution of these two statements, you can understand the memory representation, this one, above one. Okay, after execution of these two statements, this memory representation you can consider. For B1, memory is created. For B2, we are referring the same memory. This much, I hope you people have understood. In the next line, if we say B1 is equals to null, the meaning of that is only for B1 memory is lost. Okay, memory is deallocated. We can say memory is deallocated only for B1, but for B2 still it will be there. In that way we can understand. Or else if you make B2 is equals to null, okay, if you make B2 is equals to null, only for B2 memory will be there. Memory is lost, that is memory will be deallocated, but for B1 still it will be there. That means if you delete memory for one object, it will not affect the other. Here. Okay, like this. Sorry. B1 is equals to null. So I have set B1 to null, but still for B2 we can store the values. Okay, understood? Okay, I hope you people have understood till here. If you have any doubts, you can ask. Because little bit confusion is there in these topics. We'll just try to understand. So if you want once again to make explain, so I will explain. So here methods are nothing but what we say functions in case of C and C++. Only term is different. Remaining concepts are all same. Okay. So methods are nothing but only it is nothing but functions in case of C and C++. There the term is functions. Here the thing is C and term is methods. But the difference here is in Java or in C++, we use in some classes also, but in C programming language, there is no concept called as classes. Okay, so only main function or sub functions we can say. Okay. Okay, next. The class contains two things, that is instance variables and methods. I hope you got the meaning of instance variables. These are only instance variables, width, height, and depth. These are called as instance variables. See, why they are calling it as instance means, actually in English, the meaning of instance is for example. Sometimes we say for instance. For instance means similar to that. For example, we say. So here also, why they are calling it as instance variable means, see, whenever you take these variables from the class, we will get the separate memory of these variables for every object. So that is called instance. Okay, we get the separate memory for, that is own copy of memory for every object. So it is called as instance variable. That means if we create one instance, one general structure of variables, you can create n number of objects where we get the same variables. Values we can store differently, but memory will be same. Memory will be same in the sense, say for example, say if we consider, okay, in the class box width, height, and depth. And if I create two objects, say my box 1 and my box 2. Okay, if I create my box 1 and my box 2, see, we cannot say like, for my box 1, I'm getting width, height, and depth. But when my box 2 is created, suddenly I lost variable depth. We cannot say like that. Yes, we are getting depth also, variable depth also. Or we cannot say for my box 2 only, we are getting memory of width. Nothing like that. If you are getting memory of width, height, and depth for my box 1 means, for my box 2 also you are getting the width of memory of width, height, and depth. That means if we create one general structure of variables, that general structure is called as a class. If you create one general structure of variables, you are getting n number of memory. That means for n number of objects, we are getting separate memory. So it is called as instance variables. Okay. So class contains two things: instance variables and where we are. So instance variables and methods. So now if I want to include a method in the class, so what rule have to follow? So we will see. Because till now we have discussed only about variables in the classes. In classes we can write both variables and methods. In C++ also. Private, public, protected section we have. So in private section generally we write data members, that is variables. In public section we write the methods. Okay, so general form of method. See, this is very much similar to C and C++. That is, first we have to write the data type, that is called as return type. Okay, method name is nothing but an identifier. So whenever you write the identifier, you have to remember the identifier rules. Then parameter list is nothing but the list of variables. Separately you have to write. So for example, if I have A, B, C with the data type int, I have to write int A, int B, int C compulsory. You should not say int A, B, C. Even though variables belongs to same data type, you have to write it as separate declaration in case of parameter list. Then comes the body of the method. Body of the method means any Java code you can write here. Okay. So in the above form, type refers to the type of the data returned by the method. That is return type. So in C and C++ also same meaning. So data type is nothing but here return type. Okay. Name refers to the name of the method. So as I said, it is an identifier. See, wherever you come across the word identifier, you remember the identifier rules. Okay. Parameter list. So parameter list are also identifiers only, list of identifiers with their types. Types means data type separated by commas. If the method has no parameters, then the parameter list is empty. Okay. So it is not compulsory that a method should have parameters. If the parameters are not there also, it is fine. Okay. That is called as no parameters. That is parameter list is empty. That is also possible. Now in this example, they have added one method to the class. So in the previous examples, methods were not added to the class. Okay, only variables were present. Here methods are added. Okay, we will see. This program includes a method inside box class. So we have named it as box demo 3 Java. Whenever you look at the file name, you just try to understand. Say I have used a class called as myBox up to here. Then box demo 3. In box demo 3, I have used the main function. So I have named it as box demo 3 dot Java. Okay, it is not box dot Java. It is box demo 3 because in the box demo 3 class main function is there. Yes. Next, same variables have taken width, height, and depth. Okay. And then in the volume method, so this is the method, volume is the method. In C++, it is called function. System.out.print, volume is system.out.println, width into height into depth. So here only it will calculate. In the println function only it will calculate. We can calculate like that. Okay, it's not a problem, we can calculate. Here, this asterisk symbol is not the concatenation operator. So it is possible to do multiplication. If you use plus, it will concatenate. Plus is a concatenation operator in println function. If you use star or minus, it is a it does its operation. So it's multiplication operator. Okay. Next. So in the main function, we see what happens. Public static void main box my box. So we have created one object. Next, second object. For first object, we are storing the values. Okay, next for second object, we are storing the values. Now you see how to call the method. Okay, I want to execute this method. So how to execute this method means on which object you have to use this method, you have to see. Now I want to use on both objects, that is my box 1 and my box 2. So you have to write statements like this. See, display the volume of first box, my box 1 dot width, object name dot operator, method name. This is the formula. Object name dot operator, method name. If you want to call the method which is present inside the class. Okay. Next, calculate the volume. That is display the volume of second box. My box 2 dot volume. So here also object name dot method name. Okay. See here, you see the output here. Okay. The output is for my box 1, you look at the values. For my box 2, look at the values. For my box 1, values are 10, 20, and 15. If you want the memory representation, you can consider this memory representation only. This only. Memory representation is this only. It is common. We have taken the same values 10, 20, 15, 3, 6, 9. Two objects we have created. Only difference between this program and the current program is in this program we don't have method. That means we have not calculated volume by using method. See here. Directly we have calculated in the main function only. In the class I have not used the volume method, but in the last program, that is what we are dealing now. So in this we have created the function. We have created one method inside the class. Okay.